Section 8.2, the reciprocal function family. By the end of today's lesson, students are going to be able to graph the reciprocal function. The general form of the reciprocal function is y equals a divided by x minus h plus k. Every reciprocal function is going to have a vertical asymptote. I will normally write the vertical asymptote as the VA, so that way we're not writing that out every time. And the vertical asymptote is going to come from the denominator. So, to find out what our vertical asymptote is, we take the denominator, which is x minus h, and we set it equal to 0 and solve for x. So that would mean that my vertical asymptote was x equals h. These graphs are also going to have horizontal asymptotes, which we consider the HA. And depending on the reciprocal function, the horizontal asymptote could change. So for the time being, it's the number at the end. So our horizontal asymptote is y equals the k that's at the end. Our domain is going to be everything except for my vertical asymptote. So from h, and then from h to infinity. And then your range will be the same thing, only from your horizontal asymptote. Let's look at our first graph, and we're going to state a bunch of new characteristics. So we have y equals 3 divided by x plus 5 minus 4. So let's start by finding our vertical asymptote. And the vertical asymptote comes from the denominator. So the denominator is x plus 5. Solve for x, and your vertical asymptote is at negative 5. Now let's move on to the horizontal asymptote. So the horizontal asymptote for the time being is the number at the end. Let's start by making a graph and drawing our vertical and our horizontal asymptotes. Okay, so our vertical asymptote is at x equals negative 5. And our horizontal asymptote is at y equals negative 4. Okay, for the time being, your graph cannot go through either of those asymptotes. So to begin finding our points, we're going to start by finding the X-intercept. So to find the X-intercept, we plug in 0 for y. So we have 0 equals 3 divided by x plus 5 minus 4. So we're going to add 4 first. And then we're just going to cross multiply. So that's going to give me 4 times x plus 5 equals 3. To get rid of the 4, we're going to divide by 3. And then we are going to subtract 5 from both sides. So we have x equals 3/4 minus 5. We have to multiply the 5 by 4 over 4, so that way they have the same denominators. So negative 5 times 4 gives me negative 20. And 3 minus 20 gives me x equals negative 17/4. Okay, so it's the point negative 17/4, comma 0. So let's go and let's graph that point. So our x-intercept, so it's negative 17/4, which is a little past negative 4. So like right here somewhere is my x-intercept. Okay, now we're going to find our y-intercept. To find our y-intercept, we're going to plug in 0 for x. So that gives me y equals 3 divided by 0 plus 5 minus 4. So 0 plus 5 is 3/5. Minus 4, we have to multiply this by 5 over 5. So 4 times 5 again is 20, and 3 minus 20 gives me negative 17/5. So we write that as the point 0, negative 17/5. So let's go and let's graph that point. Negative 17/5 is a little past negative 3. Okay, and on your left-hand side, I have 2 points. On the left side of my vertical asymptote, I have 2 points. So I get to connect them to make my branch. Okay, so this is considered a branch. All right, if you didn't have 2 points on your right-hand side like we had there, we would have had to have picked an x value to plug it in to get our other points. So now since we have 2 points on the left side of our vertical asymptote, we now need 2 points on the left side. So I'm going to plug in -6 and -7 in for x. So let's see if I can find a spot to write that in. So y equals 3 divided by -7 plus 5. I'm sorry, let's start with -6. Let's plug in -6. And then we'll do -7. So -6 plus 5 is -1. 3 divided by -1 is -3. And -3 minus 4 gives me -7. So it's the point -6, -7. Okay, now let's plug in -7 like I was trying to do earlier. Okay, so -7 plus 5 is -2. 3 divided by -2 is -1.5. -1.5 minus 4 gives me -5.5. So we're going to graph the point -7, -5.5. Okay, 2 points make a branch. Can't go through my asymptote, so it looks like this. So since I moved to a new slide, I just quickly sketched the graph from the other slide. So that way we can now talk about the asymptotic behavior and the end behavior. So let's start with the asymptotic behavior in the new one. Or the asymptote behavior. Okay, and I will always shorthand this as AB. Okay, and that means what's happening at your vertical asymptote, only your vertical asymptote. So my vertical asymptote has 2 sides. It has a left side and it has a right side. So we write as x goes to -5, and then this minus sign up in the air means the left. F of x goes to, and then we write as x goes to -5 on the right side, the plus means on the right, f of x goes to. Okay, so let's start with as x goes to -5 on the left. So here's my asymptote. You might want to add negative and positive on both sides. So cover up everything else, look just on either side of the asymptote. On the left-hand side, closest to this line, my graph is going down. So it's going towards negative infinity. Okay, so now as we look at -5 on the right side, so again, you look at this line, whatever is closest to it's on the right-hand side. My graph is going up towards positive infinity. Okay, now the end behavior you should be fairly familiar with. As x goes to negative infinity, f of x is going towards So as we move out here towards negative infinity, this graph is getting forever close to my horizontal asymptote. So it's getting close to -4. On the right-hand side, as we go towards positive infinity, f of x, so as I move towards positive infinity, my graph, again, getting close to my asymptote, so it's getting closer to -4. Let's add the domain. So the domain is from negative infinity to my vertical asymptote, which is at -5, union -5 to infinity. And then your range is from negative infinity to your horizontal asymptote, which is -4, union -4 to infinity. The last thing we're going to look at today is writing an equation from the transformations. So I have to give you an equation, and then you either are given a graph to determine your asymptotes, or you are told what your asymptotes are. So it says, write an equation for the transformation of y equals 5 over x that has the given asymptote. So it has a vertical asymptote at x equals 3 and a horizontal asymptote at y equals -2. So for it to have transformations, it would have to be in the general form a divided by x minus h plus k. All right, so h and k should be very easy to identify. H is 3, k is -2, and the last thing we have to do is identify what a is, and a is the number that's out on top. So your equation based on the transformations is 5 divided by x minus 3 minus 2.